This is my beginning algebra course. In the next class, you're going to take test number 2, and today we're going to prepare for that test. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now, remember, you can't take a math exam and pass it unless you study for the exam. Doing the homework and the class problems with me prepares you to study for the exam, but it doesn't prepare you completely for the exam. In order to pass this test number 2 coming up in the next class, you have to study for that test. But it doesn't matter how many times you tell students to study for an exam, they're not going to do it. So what I'm going to do now is give you practice tests. One practice test we're going to do together right now, and I'm going to give you a practice test for homework, just like we did in test number 1. And just to remind you, there's 2 reasons for these tests. Number 1, it's going to show you what the test is going to be like. So you can't take test number 2 and say, "Oh, I didn't know it was going to be like this," because you're going to finish 2 practice tests. The second reason for the practice test is it's going to force you, when I give you that practice test for homework, it's going to force you to at least do a little bit of studying. And it's not going to guarantee that you get an A. If you want to get an A, you have to make sure you know how to do every single type of problem. Go back to the notes, your notes, or you can just go to the description section and go to the time code and see the screenshots of all the work that we did. Go back to your homework. Make sure you know how to do every single type of problem. Then you'll get an A in the test. But these practice exams are not going to guarantee you'll get an A, but hopefully they'll ensure you at least pass the exam if you do that practice exam for homework. So that said, let's get started on this test, and I'm going to tell you how I want you to go through this test here as we work together. What I want you to do, you can see we have practice test version 1. You're going to do version 2 for homework. And what I want you to do is I want you to go ahead and attempt these problems on your own. For example, number 1, right now I want you to go ahead and try to attempt this problem. And if you can do it, then just do the whole thing on your own. And when you're done, you can fast forward the video and see if you got the right answer as I work out the problem myself. But if you get stuck, that's okay. You can just start the video and watch me go along with this problem. And as you start to remember how to do it, then you can stop the video and then do the rest on your own. That's how I want you to go through this test. So if you're rusty on a lot of these problems, that's okay. You can just start the video and watch me go along, but I want you to hopefully do a lot of this test on your own. Don't just watch me do every single problem. You want to, if you have an idea of how to do these problems, try to do them on your own. So that said, let's get started with number 1. So go ahead and attempt this problem if you can. If you can't, that's okay, but attempt the problem. And when you're done, start the video again and see if you got the right answer. All right, we're back. If you're not sure how to do the problem, that's okay. We have the difference of 2 squares here. Remember, there's 6 types of factoring that we learned. Greatest common factor, quadratic, difference of 2 squares, grouping, multivariate expressions, and expressions of that form. So this is a difference of 2 squares. When you have 2 terms and you have a square here and then a number that is the result of a square, that's 2 squared is 4. You have the difference of 2 squares. So whenever you have that situation, you have to write 2 sets of parentheses, and then you're going to put your x's, and then you ask what number times itself is equal to 4. What number times itself is equal to 4? Well, obviously that's 2. 2 times 2 is 4. And whenever you have difference of 2 squares, you always put a plus and a minus. All right. And if you want a more in-depth explanation of that, you can go back to, I think this is Factoring Algebraic Expressions Part 2, if I remember correctly. Okay, so now in the bottom we have a quadratic expression. How do I know that? Because there's 3 terms. Whenever there's 3 terms, there's probably going to be some sort of a quadratic involved, some quadratic expression. And when you have A quadratic expression, you know this by now, you just write two sets of parentheses, x and x, and you ask what two numbers multiply to 8 and add up to -6. What are two numbers that multiply together to 8 and they add up to -6? Think about that. Well, if you said -4 and -2, you're correct. A negative times a negative is a positive, but a negative plus a negative is a negative. Okay, so we factored the numerator and we factored the denominator, and some people might say, well, who cares? Why did we do that? Well, we did that because you see these x minus 2's? They cancel out. So now the expression becomes a lot simpler. This expression is much more simple than this expression over here. And you don't need parentheses anymore because the x plus 2 is not multiplied into anything in the numerator. And the x minus 4 is not multiplied into anything in the denominator, so you don't need those parentheses. So if you got that answer, good job. Again, if you're a little rusty on this stuff, that's okay. You can watch me do these problems. So now I'd like you to attempt this problem. And again, if you get stuck, that's okay, but attempt that problem, and when you come back, we'll do it together. All right, we're back. So the numerator, we can't do anything with the numerator, so we just rewrite it. But the denominator, that is difference of two squares. That's DOTS up there, difference of two squares. So, and the reason I know that is because we have a square here and a square here. Whenever you see two terms, oftentimes it's going to be difference of two squares. Whereas again, quadratic is three terms. And as we found out up here, this 4, that's a perfect square, but the 9 is also a perfect square, and of course x squared is a perfect square. And it's this, we're subtracting, it's difference of two squares. So we're going to square root 9. What number times itself is equal to 9? What number times itself is equal to 9? Well, that's 3. Now, because it's 9x squared, we're going to put the x's there too. Now, what number times itself is equal to 4? Well, we figured that out above in the above problem. That's just going to be 2. And because it's difference of two squares, you put a plus and a minus. And now you see where we're going with this. The 3x plus 2's on the top, they're common, so we can cancel those out. Now, a lot of students would say, oh, the final answer is 3x minus 2. It's not 3x minus 2, because the 3x minus 2 is in the bottom, you see. So you have to write 1 over 3x minus 2. Now, I know what you're thinking. You're thinking, where did the 1 come from? Well, if you divide these blue things, you get 1. So that's kind of a quick explanation of why you'd write 1 up there. That's really just something you need to get the hang of. You don't have to overthink it. Okay, so again, now the 3x minus 2 that's left over is not multiplied by anything in the denominator, so you don't need parentheses. So if you got that answer, good job. Okay, on to number 3. So as you can see in number 3, we're getting much more involved already. If you think you can try number 3, go ahead and do that. You're going to need to use the GCF factoring. You're going to factor out a greatest common factor immediately. That's the first step in the denominator and the numerator. So if you think you can do that, go ahead and try it. If you can't do it, that's okay. You can just watch me do it, but go ahead and attempt number 3. When you come back, we'll do it together. All right, we're back. So I think 2 goes into all these numbers. Do you agree with that? Also, we have x's in all the numbers. So we're going to pull out some x's. But how many x's do we pull out? Well, we're always going to pull out the smallest number of x's that's common to all of them. So x cubed is going to get pulled out. Okay, so now 2 times what number is 8? 2 times what number is 8? Well, that's just going to be 4. And x cubed times what number is equal to x to the 5th? Well, that's just going to be x squared. And that's how we're going to do this. So I'm going to keep going here. And again, if you're starting to get the hang of this, you know, stop the video and do it yourself. Don't just watch me do it. Okay, and then 2 times what is equal to negative 10? That's just going to be negative 5. And that's it. So in order to check to see if that's true, you want to take this and multiply it back in using the distributive property. Multiply it back into each one of these terms and see if you get these original terms. You need to do that every single time you use the GCF factoring method. So now we're going to divide, and we're going to do the same thing in the denominator. I don't think there's any factors common to 5 and 2, except 1, of course. But there are x's in both these, so we're going to pull out the smallest number of x's, which is x squared. And then we're going to be left with 5 minus 2x. So we took 2 x's out of here, so there's only 5 left. And then we took 2 x's out of here, so there's only 1 x left. You see that? This is all review stuff. This should all be review for you. If you're rusty, that's okay. But if you've never seen this, that means you are not actually doing the work in my class. You need to do the homework and watch my videos and do the problems with me when I tell you to do them with me, so you can get the hang of how to do this stuff. Okay, so now we're still not done factoring. We just factored GCF, the greatest common factor, in the numerator and the denominator. The problem is, you see this here? That's a quadratic. So we have to continue to factor that. And so I'm going to go down here. Well, maybe I'll try to go to the side if I have some room. And so I'm going to factor that quadratic. And remember, a quadratic's always 2 sets of parentheses. Now, you see this number in front here? That messes everything up. That makes this a lot harder. Usually what we do is we ask what 2 numbers multiply to negative 5 and add up to negative 8. In this case, we're going to ask what 2 numbers multiply to negative 5, but they're not going to add up to negative 8. Why? Because of that 4. That 4 messes everything up. So the first thing we're going to do is we're going to ask what 2 numbers multiply to 4. Well, there's 4 times 1 and there's 2 times 2. So we could try 4x and x. 4x times x is 4x squared. And then we're going to ask what 2 numbers multiply to negative 5. So I'm going to say negative 5 and positive 1. Now the 1 might go here or it might go here. I don't know. When you're dealing with these problems where you have a coefficient in front of the x squared, you just have to use trial and error. So now we have to use FOIL. Remember FOIL. And we have to do FOIL on this product of binomials to see if we actually get to this expression here. So f of FOIL, 4x times x, is 4x squared. O of FOIL, 4x times 1, is 4x. I of FOIL, negative 5 times x, is negative 5x. And L of FOIL, negative 5 times 1, is negative 5. So now we just combine the inner terms and see if we get negative 8. So if we combine these inner terms, you see we get negative x. That's not negative 8. It didn't work. Okay, so what we can do is we can try switching the 5 and the 1. I'm going to put the 5 over here, and I'm going to put the 1 over here. Now let's try it again. Let's try FOIL. F, O, I, L. 20x minus x is 19x. I don't want 19x. I want negative 8x. That didn't work. So what does that mean? Well, it means it's probably not going to be 4 and 1. It's going to be 2 and 2. And I know what you're thinking. You're thinking, I don't like this. I don't like having to do this. This is tedious. Well, it's only tedious when you have this coefficient on the x squared. You know, if we didn't have that coefficient, it wouldn't be so tedious. And most of the time, you're just going to get the right answer just by chance. But we kind of got unlucky this time. It seems like every attempt we're making is wrong, but that's okay. And by the way, I'm going to rewrite that 5 minus 2x there. So now we're going to do FOIL again. 2x times 2x, that's f of FOIL, is 4x squared. 2x times 5 is 10x. Negative 1 times 2x is negative 2x, and negative 1 times 5 is negative 5. So 10x minus 2x is 8x. That's what I want. The problem is it's positive 8x. I don't want positive 8x. I want negative 8x. But that's okay because all you have to do is just switch the signs. This is negative, so you switch it to positive. And this is positive over here, so you switch it to negative. Okay, so we took this quadratic and we factored it to that there. Okay, so now we'd like to start canceling things out. I'd like to cancel this and this, but I can't. I can't do it because they're not the same. This has a positive 2x and this has a negative 2x. This has a negative 5 and this has a positive 5. So what we have to do is we have to use the negative 1 rule. We have to factor out negative 1. We could factor out negative 1 up here, or we can factor it down here. It doesn't really matter. I'm just going to factor it on the bottom. So I'm just going to rewrite the top, the numerator, and the bottom I'm going to factor out a negative there. And now that becomes negative 5 plus 2x. It was a positive 5, but then it became a negative 5. And it was a negative 2x, but now it became a positive 2x. And the negative I factored out here. Now, if you want to see why that works, then you just take that negative and you just use the distributive property and multiply it back. And you see you get back to the normal expression, the original expression. So why did we do that? Well, now because these yellow things here, they cancel out. Now, you might be thinking, wait a second, those don't look the same. But they are the same. The terms are just flipped. You have a negative 5 and negative 5. They're both negative. You have a positive 2x, positive 2x. So even though they don't look the same, they're the same. So we're going to cancel those out. Also, we have some x's here that we can cancel out. There's 2 x's in the bottom and 3 x's on the top. So the 2 x's in the bottom are going to cancel out 2 x's in the top, so you're going to be left with only 1 x in the top. And then we're left with 2x plus 1. And we need to write that negative. So it looks like everything in the denominator just kind of canceled out. And we're left with negative 2x times 2x plus 1. So if you got that answer, that's very good. Good job. Again, if you're rusty on this stuff, that's okay. All right, on to number 4. So I want you to try number 4. We have a multivariate algebraic expression. We have the difference of two squares. And these you really can't do anything with. So go ahead and try number 4 if you can. And when you come back, we'll do it together. All right, we're back. If you forgot how to do these, that's okay, but we have the difference of two squares. This is 1 squared, so that's how I know it's a difference of two squares. What number times itself is equal to 1? Well, 1 times 1 is 1. And remember, you always put a plus and a minus. Isn't it true that 1 times 1 is 1? That's the only number that if you multiply it by itself, you get 1. Okay, so now we're going to factor the denominator, and unfortunately we have that nasty situation again where we have the coefficient on the y squared. And I know this seems like kind of a complicated expression, but we learned how to do this. So first, because we have this coefficient, we're going to ask what two numbers multiply to 14. Now, this is kind of a clue up here. You see that 7? Usually there's something that's going to cancel out, so I'm going to say it's 2y and 7y. And two numbers that there's nothing here, okay? But if there's nothing there, what does that mean? It's a 1. So what are two numbers that multiply to 1? Well, obviously that's just going to be 1 and 1. But if you add the numbers up, you get a negative 9. So it's going to be negative 1 and negative 1. All right. So now I'm just going to rewrite this other stuff because, like I said, you can't do anything with that. But we can't just assume that this is correct. It might be wrong. So I'm going to go ahead and do FOIL. So f of FOIL is 7y times 2y is 14y squared. O of FOIL is negative 7y. Oh, whoops, I forgot to put my x's, I'm sorry. You see how it says x squared? That means instead of 1, it's going to be 1x. But of course, you don't have to put the 1. You can just put x. So f of FOIL is 14y squared. Then O of FOIL is negative 7yx. And it doesn't matter if you put the y first or the x first in this case. Commutative rule of multiplication says it doesn't matter. I of FOIL is negative x times 2y. So again, I can write this as negative 2yx, or I can write it as negative 2xy. It doesn't matter. And then negative x times negative x is positive x squared. That's L of FOIL. Now, if you combine these, you get negative 9xy. Is that what we want? Yes, that's what we want. So I got lucky there. Turned out that my first try there got us the right answer. Okay, so now you see we have these x minus 1 and x minus 1. Because there's an x minus 1 on top and an x minus 1 on the bottom, they're going to cancel out. And I also have a 7y minus x and a 7y minus x on the top and bottom, so they cancel out. So then you're just going to be left with the x plus 1 over 2y minus x. Now again, we don't need any parentheses because those expressions in the numerator and the denominator, they're alone. They're not multiplied into anything. So we don't need parentheses. So if you got that answer right, good job. Again, if you don't know how to do these problems, but you're starting to remember as I'm doing them, stop the video and do the rest of the problem yourself. Don't just watch me do it. Okay, so on to number 5. So we're dividing fractions. So when we divide fractions, the first thing we want to do before we forget or before we confuse ourselves, and by the way, go ahead and try this problem on your own. Stop the video. If you can do it on your own, do it. And when you come back, we'll do it together. So the first thing you want to do on this problem is change the division sign to multiplication and flip the divisor. So I'm flipping the fraction at the right. Because if you don't do that immediately, then you might get confused and make a mistake. So we flip the divisor and change the division sign to multiplication. So now we're ready to start factoring. And you could really start factoring even before that. I mean, you don't have to do it exactly this way. So now we have GCF. We have x's that are common to both those terms. So I'm going to factor out an x. And again, if you are starting to understand how to do this as I'm going along here, stop the video and do the rest on your own. We have a quadratic here. And thankfully, there's no coefficient on the x squared. So we just put an x and an x, and we ask ourselves, what two numbers multiply to negative 14 and add up to 5? What are two numbers that multiply to negative 14, multiply together to negative 14, and they add up to 5? Well, I think that would be positive 7 and negative 2. And then we're going to factor out a greatest common factor down here. So 5 goes into all those numbers. I'm going to pull out 5. And also we have x's that are common, so pull out the smallest number of x's. And so then we have x plus 7, because 5 times 7 is 35. Okay, and at this point, now we're ready to start canceling. So we have an x plus 7 and an x plus 7. We can cancel those out. And we have some x's that can cancel out here and here, but that's about it. So we have 1x here and we have 4x's there. So that 1x on the numerator is going to cancel out one of the x's here. So you're going to be left with 5x cubed in the bottom. So I'm going to go ahead and write my fraction and write 5x cubed before I forget that. And it's very important to understand that this x plus 7 here did not cancel out because you only have one x plus 7 on the top, and you already canceled that out with the blue x plus 7 at the bottom over there. So that's not going to cancel out. That's still going to be there. Also, the x minus 2 is still going to be there. And we're just left with x plus 1 in the top, and that's it. There's nothing else that we can cancel out. So I think that's about it on that problem. So if you got that one right, good job. Okay, so now we're doing something completely different. These problems, we multiplied and divided those algebraic expressions, but now we're going to add and subtract algebraic expressions. So remember, when you add or subtract algebraic fractions, you have to get a common denominator. And the first step to getting a common denominator that is, and be aware, we want the simplest expression for the common denominator. You can probably find a common denominator just by multiplying these together, but that would be really, really convoluted algebra. So in order to get the simplest denominator, you want to factor this quadratic. That's calling out to you to factor it. So go ahead and attempt number 6. If you get stuck, that's okay, but attempt number 6. When you come back, we'll do it together. All right, we're back. So again, that quadratic in the denominator is calling out to us what two numbers multiply to 2 and add up to 3. What are two numbers that multiply to 2 and they add up to 3? Well, if you said 1 and 2, you're correct. And I'm just going to rewrite that. So you don't really have to rewrite it again to show every single step, but I'm just going to go ahead and do that just so you can see what's going on here. I am now going to get a common denominator, and I can see pretty easily what the common denominator is going to be. Don't you see that this has an x plus 1 and an x plus 2, right? Well, we need an x plus 1 and an x plus 2 here also. We already have an x plus 1, so all I have to do is just multiply both sides of this by x plus 2, and bing, bang, boom. See that? Now we have a common denominator. But if I multiply the bottom by x plus 2, I have to multiply the top by x plus 2 also, the fundamental principle of fractions. If I don't do that, then the fraction changes values. So now I'm just going to rewrite this. And I have to use the distributive property. 5 times x plus 2, that's 5 times x is 5x. 5 times 2 is 10. And I'm just going to keep it in factored form in the bottom. So again, because we have this common denominator, we can go ahead and add these up. So 3x plus 5x is 8x, and there's nothing else to add 10 to, so we can just write the 10, and we can just keep the denominator in factored form. A lot of students say, well, don't we have to multiply that denominator? Don't we have to multiply it to get x squared plus 3x plus 2? Well, not really. You can just keep it in factored form. That's fine. So if you got that answer, good job. Now again, if you're getting stuck on these problems, like I said, that's okay. But once you start to understand, once you start to remember how to do it, start doing it on your own. Don't just wait for me to do the whole problem. Your mind is going to be, you're going to absorb this information 1,000 times more efficiently if you actually do the problems yourself. Okay, so now we're going to subtract these fractions. If you want to attempt this problem, go ahead. And when you come back, we'll do it together. If you want me to get you started, then we'll do that now. So this is going to be quite a bit different than the previous problem. Maybe I should show that problem in the window. You get a screenshot of that. So we have an x minus 3. We have an x and we have a 3. So that's 3 different things to deal with. All right. So over here, I already have a yellow 3 and a blue x, but I need a purple x minus 3. So I'm going to multiply both sides by x minus 3 to get a common denominator. So now I have all 3 of those species, this yellow one, the blue one, and the purple one. I think I'm getting kind of crazy with the colors there, so I'm going to back off that. Okay, so now I have a blue and a purple. So all I need is a yellow, so I'm just going to multiply both sides by the yellow 3. Remember, when you multiply one side of a fraction, you have to multiply the other side too, the numerator and the denominator. And there you go. Now I have a common denominator, you see. So let me just double check, see if this is all right. Everything looks correct. And now we're going to use distribution to multiply this numerator. So that would be 2 times x is 2x, 2 times negative 3 is negative 6. And I'll just rewrite the denominator. Use distribution up here. That would be 3x plus 21. And again, we can just keep the denominators in factored form. That's kind of a waste of time to put that, to distribute that. So again, because we have a common denominator, we can add these expressions, or in this case, we're going to subtract them. So now this is the part where students get into trouble. You see how you're subtracting this entire fraction? If you're subtracting this entire fraction, then that means every single one of these signs has to change. Now, this is a positive 3x, right? If you're subtracting it, it becomes a negative 3x. So we have 2x minus 6 minus 3x. And instead of positive 21, it's going to be minus 21. So that's a part where a lot of students have trouble with that. They get that wrong. Whoops, that should be a 3 there. That should be a 3 rather than a 2. So now 2x minus 3x is negative x, and negative 6 minus 21 is negative 27. And we can just rewrite the denominator, and there you go. So if you got that answer, good job. Okay, on to the next problem. These are much easier problems down here. Says find the square roots. You will have to approximate one of the roots with a calculator round to the nearest thousandth. So the one you'll have to approximate with a calculator will be this one, because root 17 is not a perfect square, so we can't really do that without a calculator. We can't approximate it. So go ahead and try part A here, see if you can remember how to do this one. And when you come back, we'll do it together. If you want me to refresh your memory, we'll go ahead and do that now. So we're going to use this principle that we learned. The square root of A over B is equal to the square root of A over the square root of B. That's a principle that was really useful to us, and we learned that. So this is going to be equal to the square root of 36 over the square root of 81. And what number times itself is equal to 36? What number times itself is equal to 36? Well, that's going to be 6. And what number times itself is equal to 81? That's going to be 9. So then 6 over 9, it just so happens we can reduce that, divide both sides by 3, and we get 2 over 3. So the answer to that problem was 2 over 3. And I'm going to move this out of the way here. So if you got that one right, good job. Part B is going to be pretty easy. Why don't you go ahead and try part B? When you come back, we'll do it together. All right, we're back. What number times itself is equal to 16? Well, that's just 4. So that one's pretty easy. Let's try part D here. What number times itself is equal to 1? Well, that's just going to be 1. So we got that one right. Good job. But now for part C, we're going to have to use the calculator. So I'm going to use my iPhone. Remember, it's different depending on what phone you're using or what calculator you're using. I'm going to rotate my phone in landscape, and I'm going to type in 17, then I'm going to push the square root button. And the square root button on the iPhone looks like it looks like this. In case you don't remember, that's the square root button. So you put 17 in first, then you push this yellow button here. It's not yellow on your calculator though, obviously. Now be aware that if you're using an Android phone, you might have to push this square root button first, then you put in 17. So just be aware it's different depending on what calculator you're using. So anyway, you want to put squiggly lines because it's an approximation, and it's going to be 4.1231056, and it just keeps going on. But we're going to round off to the nearest thousandths. You see this blue thing up here? It says nearest thousandth place. So that's going to be here. So what we do is we look to 1, and the 1 tells us to round up or down. So because it's 1, we're going to round down, and all these numbers then become 0. But of course, you don't have to write those 0 numbers. You just write 4.123. So if you got that answer, good job. It's very important to put squiggly lines, though. All right. If you don't put squiggly lines, then you're saying it's exactly equal to 4.123, which is not correct. That's not a correct mathematical statement. Okay, so if you got those right, good job. Now we're going on to number 9. Now we're going to factor out a perfect square. So if you remember how to do this, just go ahead and do it. If you don't remember, we're going to do it right now. So there's a perfect square in 20. So I'm going to factor out 20, or I'm going to factor out 4 out of 20. Now it's very important to understand that you could factor and make it 10 times 2. The problem with 10 and 2 is neither of them are perfect squares. We want a perfect square, 4. Okay, also you want the other number hopefully to be a number that doesn't have a perfect square. So now we're going to use this principle that we talked about. Remember, square root of a times b is equal to square root a times square root b. That's the multiplication equivalent of this green expression up here, you see. So we did a division up here, but multiplication, we also have a principle. So what that means is we're going to separate it to square root 4 times square root 5. Now, the square root of 4, what number times itself is equal to 4? That's just going to be 2. And then, of course, we can get rid of that dot. And I want you to understand that I'm showing a lot of steps here that you don't really have to show. In fact, you can do all of this in your head. I'm not going to require you to show work on that. But I'm just showing you, the process here. If I go from here to here, then students will complain and say, well, you didn't tell me how to do that. But on these particular problems, if you're doing a problem like this, you have to show all this work. Okay, you can't just go from here to here, because I don't even believe that a student can do that in his or her head. It's not that you can't do it, it's just that, why would you even want to? You want to write that stuff down. So if you just go from here to here and you're taking a test, your teacher's just going to give you an F. He's going to assume that you just cheated. You looked on somebody's paper, because you need to show the work. And even if you could do this in your head, it doesn't matter. You need to show how to read and write all these steps. The purpose of this course, primary purpose, is to learn how to read and write the math. And if you're jumping to the answer, you're not really showing that you can communicate to another mathematician how to do the problem. So go ahead and try part B. And again, if you want to just do it in your head on this particular problem, you can do that. Just go straight to the answer. When you come back, we'll do it together. If you don't remember how to do the problem, then we'll do it now. So that's root 9 times 5. I'm going to break it up into root 9 times root 5. Root 9 is just 3. And of course, we don't really need the dot, so we just get rid of that dot, and we have 3 root 5. So if you got that answer, good job. Okay, so now we're going to add, subtract. These are pretty easy problems. You know, these root 3s, you see, are root 7s. You see how they all have root 7s? That means they're like terms. You can just go ahead and combine those. So try it part C. When you come back, we'll do it together. All right, we're back. 1 root 7 plus 4 root 7 is 5 root 7. 1 apple plus 4 apples. 1 apple plus 4 apples is 5 apples. Okay, it's both apples. 5 apples minus 10 apples is negative 5 apples. I understand it's impossible to have a negative apple, but you get the point. We're dealing with like terms here because they all have root 7s. Okay, so if you got that answer, good job. Go ahead and try part D. And when you come back, we'll do it together. All right, we're back. So negative 8 minus 2 is negative 10. And negative 10 plus 4 is negative 6. So if you got that right, good job. Again, those are all like terms. You could say it's oranges, 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 because they all have root 3s. Okay, now going on to number 10. It says multiply, but never leave perfect square factors under the root signs. So what does that mean? Well, here we have a perfect square factor under the root, and we pulled it out to get 2 root 5. So that's what I'm talking about there. Okay, so root 2 times root 2. Now, in this case, we're going backwards. You see this green thing up here? I'm going to pull that down. I need that. I'm going to pull that down here, and I'm going to reverse this. If root AB is equal to root A times root B, then root A times root B is equal to root AB. So I just flipped it around. You see that? I just flipped the equation around. So if you multiply roots, then you just combine it as one root, and you just multiply whatever was inside. So then we get root 4, because 2 times 2 is 4. But what is root 4? Well, root 4 is just 2. What number times itself is equal to 4? That's just 2. So that problem was pretty easy. And if you want to, you can attempt part B. Remember, never leave a perfect square factor in the root. And when you come back, we'll do it together. If you're not sure how to do it, let's get into it here. So negative 1 times 3 is just negative 3. Root 6 times root 10, that's just going to be root 6 times 10. All right, again, using this green principle up here. And 6 times 10 is 60. The problem is there's a perfect square factor in 60. So I'm going to factor it to 4 times 15. Why did I do that? Because 4 is a perfect square. All right. So now I'm going to pull out. I'm going to now reverse this equation, and I'm going to go backwards. I'm going to split it up to root 4 times root 15. And root 4, that's just equal to 2. And negative 3 times 2, that's equal to negative 6. And of course, you don't need you don't need that dot, so you can just get rid of the dot, and there you go. Now, I want you to understand very clearly, you don't have to show every single one of those steps. Now, you do have to show at least maybe, I want you to write this. So you start with the blue here, and I want you to write the blue in the middle. And then I want you to at least go from there down to possibly here. So you can skip a lot of steps. You don't have to show all of that. When you go into upper mathematics, you would never show all these steps because it would just be too tedious. If you're not sure how, if it helps you to show these steps, then go ahead and do that. But just be aware that you need to, conserve your energy while you're doing this test. So you want to jump forward on these particular problems if you can. Now, please understand that does not apply to these problems. You have to show all this work on these problems. But with the roots, you can jump forward on a lot of these problems. So if you got part B right, good job. So now go ahead and try part C. If you get stuck, you can watch me go along here. When you come back, we'll do it together. All right, we're back. Now again, if you start to remember how to do these problems as I'm doing them, then stop the video and do the rest on your own. 4 times negative 3 is negative 12. And root 14 times root 2 is root 14 times 2. And now I just want to show you what I mean when I say jump forward here. So if I were to do this problem on my own, I would write negative 12 and then I would just multiply 14 and 2 and to get 28. You can just skip right down to that step if you want. Then I know that 28 is 4 times 7, so 2 is going to come out. Multiply into, because root 4 is 2, it's going to come out, multiply to 12, get 24, and the 7 is going to be left in, and that's all you really have to show for these root problems. Okay, but I don't want students to get confused if you're not sure where that's coming from. So I'm going to go ahead and show these steps, but don't think that you have to show every single step necessarily. Okay, so now I use the green principle to get to here, and we have 28. So now I can't leave perfect square factors inside the root. So I'm going to factor that to 4 times 7 like we talked about before. And then I'm going to separate to root 4 times root 7. And a root 4 is just equal to 2. And negative 12 times 2 is negative 24. And of course, we can just get rid of that dot. We don't need that. And that is the final answer. So if you got that answer, good job. So for part D, you're going to need to use the distributed property. You're going to take this negative 9 root 5, and you're going to multiply it into each one of these terms. Try D, and when you come back, we'll do it together. If you're not sure how to do it, let's do it now. Negative 9 times 2 is negative 18. Root 5 times root 2 is root 5 times 2, again, based on that green principle up there. So we multiplied negative 9 root 5 times 2 root 2. So now negative 9 root 5 times negative 6 root 5. Negative 9 times negative 6, that's going to be positive 54. And then root 5 times root 5 is root 5 times 5, again, based on that green principle. Now we're going to do negative 9 root 5 times root 15. Negative 9 times 1 is just negative 9. And root 5 times root 15 is root 5 times 15. I'm going to move that over a little bit. Okay, so again, you don't have to show every single one of these steps. So now negative 18 root 10 plus 54 root 25 minus 9 times, what is 5 times 15? That is 75. So now we can continue to simplify here. There's nothing we can do with root 10. But I know that root 25 is just 5. And we're going to have to pull out a perfect square out of that 75. So I know that 75 is 25 times 3. Now you might say, well, wait a second. How come you didn't just keep it factored like this? Well, because neither 5 nor 15 are perfect squares. 25 is a perfect square. So I put it together as 75, and then I took it back apart. And you don't really have to put it together to 75. You can kind of just factor 5 times 3 and then put the 5s together to get 25 times 3, but that may be a little more complicated than you want. Okay, so now negative 18 root 10 plus, what is 54 times 5? That's 270. And then we're going to use the principle where if you have the root of a product, you just separate those. We have root 25 times root 3. So rewriting this other stuff, nothing we can do with the other numbers now. Root 25, that's just 5. And 9 times 5. Again, you see how I'm showing all this work? You don't have to show all this. 9 times 5 is 45. And I'm just going to skip right down to the, put the root right next to there. I don't want to rewrite all that stuff just to show you can get rid of the dot. So there you go. If you got that answer right, good job. So now let's go down to number 11. This problem is going to be pretty easy. Negative 9 times negative 8 is 72. And that's pretty much it. That's all you can do on that problem. Try part B of 11. And for part B of 11, I'm going to bring this green expression down for you. That might be useful to you for that problem. But for this problem, you're going to have to reverse it. I'm going to take this, throw it over there, and I'm going to take this right there. So I'm basically just flipping the equation around. So I'm going to give you a hint here. Go ahead and try part B, and when you come back, we'll do it together. All right, we're back. So that becomes root 72 over 8 if you use that green expression. Now, why did we do that? Well, because 72 divided by 8 is 9. So that makes things a lot simpler. So now, what is the square root of 9? What number times itself is equal to 9? Well, that's just 3. So there you go. So you can see that some of these problems are fairly easy. Other problems are not easy. It takes a lot of algebra to do a lot of these problems. Okay, so in the next problems, we're going to need both the multiplication principle and the division principle. So I'm bringing both those up there. It says here, rationalize the denominators. And we're still on number 11, I believe. Rationalize the denominators. We cannot have roots in denominators. Remember that? We're not allowed to have roots in denominators. So what I'm going to do is I'm going to rewrite this, and then I'm going to multiply both sides by a root 6, because that's the only thing that's going to get rid of that root, is multiplying it by itself. So then we end up with 2 root 6, and then root 6 times root 6. I'm going to use this principle up here. And so I have root 6 times 6. I combine those. All right, so now we end up with 2 root 6 over root 36. 6 times 6 is 36. And then what is the square root of 36? What number times itself is equal to 36? Well, that's just 6. So we have 6 there. And then this is the part that might confuse students, but you have a 2 over 6 there. You can reduce that to 1 over 3. So we can put root 6 over 3. And you can put a 1 right here if you want, but that's not really necessary. It's not traditional to do that. And at that point, we rationalize the denominator. We're done. All right, so part D is going to be more difficult because there's a perfect square factor in 32. For part D, you're going to have to do two things. You're going to have to get rid of the root in the denominator, but first, before you do that, you're going to have to get rid of the perfect, or you're going to have to pull out the perfect square factor in 32. So you can try D if you want to. If you get stuck, then you can go along with me. So let's go ahead and try part D. I'm going to first pull out the perfect square, and you can rationalize the denominator first. You can do it that way if you want to. The problem is the numbers are going to be huge that you're going to have to deal with. If you want to get smaller numbers, you want to pull out the perfect square first. So I'm going to factor that to 16 times 2, and you might be thinking, well, how am I supposed to know that 16 times 2 is equal to 32? Well, you can just play around with the numbers. We know it's 4 times 8, but if we factor 8, that becomes 4 times 2, right? Put the 4's together, you get 16 times 2. See how I put these 4's together to the 16? So that's how you come up with that stuff. You want one number that has no perfect square factors, and you want another number that's a perfect square. That's what we're looking for when you pull out the perfect squares out of roots. So at that point, we're now going to use this principle, but now going in the reverse direction from here to here. So we have root 16 times root 2. And why did we do that? Well, because root 16, that's really easy. What number times itself is equal to 16? That's just 4. And now, just like in the previous problem, we can actually reduce this. What's 12 divided by 4? That's just 3. And so there you go. Now, a lot of students would be tempted to say, okay, we're done. We finished. But all we did there was just pull out the perfect square factor out of 32, or square root 32. Now we have to rationalize the denominator. So now we're starting where we started on this particular problem. We have to get rid of that root in the denominator. So let's go to it. I'm going to rewrite that fraction. And again, I want to remind you, when it comes to these roots, you don't have to show all these steps. If you know how to do the problem, then just skip forward. And I'm going to multiply. Maybe I should use different colors. I'm going to multiply both sides by root 2. In fact, maybe I'll do that up here. I'll turn these to greens. So I'm multiplying both sides by root 2, and I just get 3 root 2 over root 2 times 2. Again, I'm using that green principle up there, up here. And so now we have 3 root 2 over root 4. But what is the square root of 4? Square root of 4, what number times itself is equal to 4? That's just going to be 2. And now we're done because we don't have a root in the denominator anymore. And we don't have a root with a perfect square. So if you got that one right, good job. Okay, on to number 12. Now this is a complex fraction. Now remember, this is a division. This is a fraction symbol, but fraction symbols can be interpreted as division symbols. So that just becomes 2/3 divided by 4/5. Right? That yellow division symbol just became the yellow fraction symbol became the division symbol, you see. So now it's just basic arithmetic. We're just dividing fractions. You did that in my arithmetic course or whatever arithmetic course you took. So remember, you do two things when you're dividing fractions. You flip the divisor and you change to multiplication. Now it just becomes a multiplication problem. So now you just multiply straight across. 2 times 5 is 10, and 3 times 4 is 12. We just have to reduce that, divide by 2, and you get 5 over 6. On to part B. So if you want to try part B, go ahead. But it's really just the same situation. We're going to change that fraction symbol into a division symbol. So we have 4 divided by 1/3. But a lot of students get stuck here. They think, well, what is going on here? But the 4, you can just write it as 4 over 1. You see, so now we're just dividing fractions just like we divided up here, you see. So now you do two things when you're dividing fractions. You flip the divisor so it becomes 3 over 1, and then you change the division sign to multiplication. And they're just multiplying straight across. 4 times 3 is 12, and 1 times 1 is 1. And you can write the final answer as 12 over 1, but if you become an engineer and you write your 12 as 12 over 1, they're going to laugh at you. The other engineers are going to laugh at you, so you want to write that as just 12. All right? So if you got the answer, good job. Go ahead and try part C. See if you can do part C. When you come back, we'll do it together. All right, we're back. So we have 8/7, and again, we're going to change that fraction symbol to a division symbol. Remember, fraction symbols can be interpreted as division. And now we're dividing by negative 2x. Now, you don't want symbols together like this. That's not allowed in mathematics. So you want to put a parentheses there. And so at this point, again, a lot of students will get stuck because they see this and they don't really understand, how do we do that? But if you write negative 2x over 1, then that's probably going to jumpstart your mind. You're going to realize what you have to do. So remember, when you're dividing fractions, you just change to multiplication and flip the divisor. So now we have negative 1 over 2x. And now we're just multiplying fractions. So multiply 8 times 1, you get 8. And then 7 times negative 2x is, or just 7 times 2x is 14x. And you can put the negative, it's traditional to put it in front. Problem is we can reduce this. 8 over 14, you can reduce that. So I'm going to shrink this a little bit. All right, so we can reduce 8 over 14. That just becomes 4 over 7. And that's the final answer. So if you got that answer, good job. Okay, on to part D. So now this complex fraction is becoming more and more complex. In this case, what we have to do is we have to combine these fractions, get a common denominator, combine those, and then we have to get a common denominator and combine these before we do anything else, before we worry about, interpreting this fraction symbol as a division. So I'm going to multiply both sides of this fraction by 5, and I get 15 over 40. I'm going to multiply both sides of this fraction by 8, and I get 8 over 40. So now I have a common denominator, right? I'm going to multiply both sides of this fraction by 10, and just keep the other fraction the way it is. And I get 90 over... Wait, did I say 10? No, I'm sorry. Multiply both sides by 2. And I get 18 over 20. All right, and so now I can combine these. So 15, we have a common denominator, 40, so we can subtract. 15 minus 8 is 7, so we get 7 over 40. Just waiting for my computer to speed up. 7 plus 18 is 25, so 25 over 20. And please be sure to make this fraction longer than the other ones, or else things are going to get really confusing. The fraction symbol, that is. Okay, so now we can reduce this fraction to make the numbers smaller, which is going to be very beneficial because it looks like we're going to have to multiply eventually. So I'm going to change that to 7 over 40 divided by, if we divide both sides by 5, we get 5 over 4. It's a lot easier to work with. And now we can interpret that fraction symbol as division. So it becomes 7 over 40 divided by 5 over 4. So again, we took that fraction symbol, interpreted as division. And of course, when you're dividing fractions, you just change to multiplication and flip the divisor. So we have 4 over 5. And now you can just multiply straight across. And if you do that, you get 28 over 200. But obviously, that can be reduced. So an easier way to do that is just to go ahead and, reduce these first with cross canceling. But if you divide both of these by 4, you get 7 over 50, it looks like. Actually, no. Yeah, 7 over 50. And that's your final answer. So if you got that one right, good job. As you can see, that's a lot of math going on there. Okay, on to number 13. So if you want to attempt number 13, now we have something new here. This is an expression. That's the sixth type of factoring that we did. If you look over here, that's the factoring of this form here. So far we've done GCF, quadratic, difference two squares, multivariate expressions, and now we're doing the sixth type. We'll get to grouping later on. So let me bring this over. Okay, so if you want to go ahead and attempt this problem, if you can, and this is just going to be the difference of two squares, but it's x to the 4, so that kind of makes it weird. But go ahead and try number 13. When you come back, we'll do it together. All right, we're back. So the first thing that I'm going to do is go ahead and, when you're dividing fractions, you want to change to multiplication and flip the divisor before we forget and we confuse ourselves. So we'll double check that, make sure everything looks right. Everything looks good. So now we're ready to start factoring. So we're going to use GCF in the upper left. I'm going to pull out a -5. We don't really want negatives in our first terms usually, so we're going to pull out a negative. I just feel that that's going to be a negative. We're going to pull out there, and we have an x common to both those terms, and so we're left with 6x squared plus 5. And down here, I'm just going to rewrite that 2 minus x squared. And again, you just want to distribute back just to make sure we did that correctly. And over here, this is the difference of two squares. It doesn't look like a square because it's x to the 4th power. But remember, x squared times x squared is equal to x to the 4th. So you could write it as x squared raised to the 2nd power. You see, so technically it is a perfect square. So we have x squared and x squared. And what number times itself is equal to 4? Well, we've done that like 3 times already today. That's just 2 times 2. And remember, when you're doing a difference 2 squared problem, it's just going to be plus and minus. Then the bottom, we have a quadratic expression of this blue form over there at the right. But again, this messes things up. The 6 there, that messes things up. So what do we do there? Well, you see this 6 over here? You see the purple 6? That gives me a clue as to what it's going to be. Because usually something is going to cancel out in these types of problems. So I'm going to write 6x squared and x squared. 6x squared times x squared is 6x to the 4th power. Now we're going to ask what two numbers multiply to 10. But they're not going to add up to 17 because the 6 again complicates things. So we have, again, this is a clue over here. That's a 5. So I'm going to write plus 5 there and plus 2. And we have to try it to see if it works. So we don't really have to use the F and the L of FOIL because we designed it so that those work. So all we need to really do is just use O and I of FOIL. So O is going to be 12x squared and I is 5x squared. Add those and you get 17x squared. So that's exactly what we want. Again, as you learn this stuff, you should be going faster and faster as you learn how to do these problems. That's what's going to happen as you go into upper mathematics. You're just going to get faster and faster and faster with these problems. Just like when you learn the English language, when you're a child, you don't speak it very well, but as you speak the language more and more and more, it gets to the point where your brain just starts doing things very quickly, and without even thinking, you have these algorithms in your brain that just tell you what sounds to make, and it happens very quickly. So now we're going to cancel out the x squared, 6x squared plus 5, and we're going to cancel out the x squared plus 2. But I noticed something. That is this 2 minus x squared here. That looks a lot like this this x squared minus 2. It's not the same though. So what do? Well, we have to use the -1 rule. And I'm thinking that maybe just to be absolutely complete here, you don't have to show every step like this, but just to be absolutely complete, I'm going to go ahead and rewrite all that stuff. I know that's seems tedious, but I just want to show what's happening here. So I'm going to factor out a -1, and that's going to become -2 plus x squared. And I'm just doing this so we can cancel everything out at the same time. You don't have to cancel everything out at the same time. You can do it by steps. But I just want to show you everything here, and then we're going to cancel out as we go along. So again, if you distribute back here, -1 times -2 is +2, right? -1 times x squared is -x squared. So that shows you why I can do that. But now you see x squared minus 2 is the same thing as -2 plus x squared. They're just the terms are just flipped around. And like I said, you can cancel out your 6x squared plus 5. And you can cancel out x squared plus 2. And you can see we really don't have much left at that point. We have -5x over -1, but that's just equal to 5x. So at that point, we're pretty much done. On to part 14, or number 14. So you're probably thinking, well, we can't combine these because they're not like terms, and you're right. But here and here we have perfect square factors that we can pull out of those roots. So go ahead and try 14a. When you come back, we'll do it together. All right, we're back. So we have -10 root 7. We can't really do anything with that, but root 40, that becomes 4 times 10. And 63, that becomes 9 times 7, right? And so now we're going to use that green principle. Remember the green principle we talked about. We're going to separate those roots. And again, you don't have to show every one of these steps. Root 4 is 2. I'm just going to put that right next to the root immediately. Root 9 is 3. And then we have -10 root 7 minus 2 root 10 plus 3 root 10 plus 9 root 7, because we multiplied those 3's together. Now you see we do have like terms. We have the root 7's. We have bananas there that we're going to combine, but we also have limes that we can combine. We're going to combine limes. So 10 root 7, -10 root 7 plus 9 root 7 is negative root 7, and -2 plus 3 is just 1, so we have plus root 10. So we combined our limes to root 10, and we combined our bananas to negative root 7, and that's the final answer. So if you got that, good job. Okay, now 14b, it says factor out a perfect square. Leave no perfect square factors in the root. So we can't leave this as root 180 because there's perfect square factors. So I'm going to factor that to 18 times 10. But neither 18 nor 10 are perfect square factors. So I'm going to factor that again. I'm going to take 18 and turn it into 9 times 2. So I took that 18 and turned it into that. So then I'm going to, I'm also going to factor the 10. I'm going to take the 10 and turn it into 5 times 2. And then I'm going to combine the 2's. So I get 4. And then you see how both of these are perfect squares? 9 and 4 are both perfect squares. I'm actually going to combine those to make one bigger perfect square. So it combines to 36. And now I can just go ahead and break up that to root 36 times root 5. And root 36, that's just equal to 6. So there you go. So that was kind of a big one there to pull out all those perfect squares. If you got that answer, good job. Okay, let's try number 15, rationalize the denominators. So here we're going to have to use that principle. Maybe I should figure out where those are. We're going to have to use these principles here. And I'm going to use the one at the right, dividing. So that's just going to become, again, try this on your own. If you can do this on your own, go ahead and do it. Root 1 is just 1, root 64 is 8, and you're done. So that one was pretty easy. So now we're going to use the same principle, root 3 over root 10, break it up into 2 roots. Problem now is we have a root in the denominator. We're not allowed to have a root in the denominator. So I'm going to multiply both sides by root 10. And again, you don't have to show all the steps here, but in the numerator we get root 3 times 10. In the denominator we get root 10 times 10. And then we get root 30 over root 100, but 100 is a perfect square. So that just becomes root 30. What number times itself is equal to 100? Well, that's just 10. So there you go. All right. So now we're going to try part C. And again, if you're getting stuck, that's okay. But once you figure out what's going on, go ahead and just stop the video. Don't just watch me do it. Do it on your own. So now we're going to use that same green principle, this principle here, and we get root 49 over root 5. And root 49, that's just 7, so that was easy. Problem is now we have a root in the denominator. We're not allowed to have roots in the denominators. That's the whole point of these problems, is to rationalize the denominators. See how these denominators are inside the roots? You can't have denominators inside roots. So now we're going to multiply both sides by root 5, because that's going to get rid of the root in the denominator. Then you end up with 7 root 5 over root 5 times 5, which is a step, again, you don't really have to show. I'm just showing this so you know exactly what's going on. So then we have 7 root 5 over root 25, and 7 root 5 over root 25 is 5, and you're done. So there we go. I'm going to change this problem to 13 over 36. So let's try that problem. So root 13 over root 36, that's just going to be root 13 over 6. Square root of 36 is 6. So there you go. If you got that one right, good job. Okay, on to number 16. So now again, this is a complex fraction. If you can do this problem on your own, go ahead and do it. Don't just watch me do the problem. And we're going to have to write, well, I guess we don't have to write parentheses. So see, we changed the fraction symbol into a division symbol. Now, when you're dividing fractions, like we talked about, you're just going to change to multiplication and flip the divisor. So now we have x plus 4 over negative 1. And now you just multiply straight across. So we have 5x times x plus 4, and 6 times negative 1 is negative 6. And I guess you can distribute that if you want to. I'm going to go ahead and just distribute so you can see what's going on. So we have 5x squared plus 20x over negative 6, and that's pretty much all you can do. So if you got that one right, good job. You can leave it in this form or this form. I don't really care which form you leave it in. Okay, on to the next problem. Part B, we're going to rationalize this denominator. So we're going to have to go to the right here. Some problems you have to go to the right because there may not be enough room to go down. I don't really know if we're going to need more room on this or not. So we're going to use that principle where we split it up into 2 square roots. And there's 2 things we have to do with this problem. We have to get rid of the root in the denominator, but first we have to pull out the perfect square in 50. So I'm going to change that to 25 times 2. And then we're going to break it up using those principles I was talking about. And root 25, that's just 5. So we did it. We got rid of we pulled out the perfect square inside the root. Problem is now we have a root in the denominator. We're not allowed to have roots in the denominator. So now we're going to multiply both sides by root 2 to get rid of that root in the denominator. So then we end up with root 11 times 2 in the numerator, and root 5 root 2 times 2 in the denominator, and you get root 22, and 5 times root 4. 11 times 2 is 22, 2 times 2 is 4. Then we end up with root 22 over root 4 is 2, right? So I'm going to shrink this a little bit so we have more room. Sorry, my computer's going a little slow here. And we're almost done. We just put those together. We have root 22 over 10, and that's it. So if you got that answer, good job. So some of those root problems are really easy. Others are a little more involved. Okay, so now we have a complex fraction, so we're just going to change that fraction symbol into a division symbol as usual. And whenever you're dividing fractions, you have to change to multiplication and flip the divisor. So now we just have a multiplication problem. So we're going to multiply straight across. 9 times 2 is 18. X cubed times x is x to the 4th. And then we're just left with a y there. 5 times 2 is 10, and y to the 4th, and z. So now we can reduce that a little bit before we get our final answer. So divide both 18 and 10 by 2, and we get 9 over 2. And x to the 4th we can't do anything with, but the y's we can combine. So this one y is going to cancel out one y in the bottom. So we're left with y cubed, and we can just rewrite that z. So there you go. Oh, whoops, I'm sorry. That should not be a 2. That should be a 5. Sorry. Okay, if you got that one right, good job. So now we're going to problem 18. We have to get a common denominator here, and we have a purple b minus 6, and we have a green 4, and we have blue b's. So there's 3 different things that we need here to be common in the denominator. So b minus 6, I'm going to multiply that by 4b, the top and the bottom, by 4b. All right, and we have a green 4 and a blue b, but we don't have a purple b minus 6. So I'm going to take that 4b and I'm going to multiply it by b minus 6. And if I do that to the bottom, I have to do it to the top also. A lot of students will multiply the bottom but not the top. Well, if you do that, you're certainly going to get the wrong answer. Now I have a blue b down here, but I don't have a green 4 or a purple b minus 6. So I'm going to multiply by 4b minus 6. And you know, there's ways to kind of put these together faster. You don't have to show every single one of these types of steps, but you do have to show work. Okay, so let's see here. Just double check our work. It's always good to go back and check what you wrote. Everything looks good, and we have to, the most important thing is to check if we have a common denominator. Are all these the same? Do they have a 4b? They all have a 4b, it looks like. Do they have a b minus 6? It all looks like they have a b minus 6. So I'm just going to put, well, 2 times 4b is 8b. And I'm just going to rearrange these denominators so they all look the same. Use distribution here. We have 3 times b is 3b, and 3 times negative 6 is negative 18. And actually, this here is not good. I didn't do that properly. You can't do that. That looks like 24. So what you have to do is you have to write brackets here. Or what you can do probably better is just to write a dot. Just write a dot like that. So this here would be 8. Just to save time, I want to combine that to 8. And then we have 8b minus 48. And we should probably put a dot here also. Then we have 4b and b minus 6. So now, again, notice that all the denominators are the same. So this negative here applies to this whole fraction, so you can just kind of throw it up into the negative 8. So negative 8b plus 3b is negative 5b. In fact, I'm just going to show that. Negative 8b plus 3b minus 18b. Now, this is the part where students are going to have trouble. You're subtracting this entire fraction. This is a positive 8b, but because you're subtracting that fraction, it becomes negative 8b. This is a negative 48. Because you're subtracting this entire fraction, it becomes a positive 48. If you're going to get problems wrong on the test, that's probably where it's going to happen. When you're subtracting a fraction, you have to change the signs, each one of the signs in the entire fraction, the numerator, if you have a sum or difference of terms in the numerator of the fraction that you're subtracting. Okay, negative 8b plus 3b is negative 5b. Negative 5b plus negative 8b is negative 13b. Negative 18 plus 48 is 30. So that's going to be 30. And the denominator we can just rewrite 4b times b minus 6, and that is the final answer. All right, going on to number 19. You can try these problems if you want, rationalize the denominators. So go ahead and try. When you come back, we'll do it together. All right, we're back. We've got 2 problems. We have a perfect square factor in here, and we also have a denominator in the root. So first I'm going to take care of the, I'm going to use the principle, the green principle there. And then I'm going to pull out the perfect square factor, and we're kind of pressed for time here, so I'm just going to factor that to 16 times 3. Again, you can just use a factor tree to show why that is. And then we have root 16 times root 3 over root 5. Root 16 is just 4. So we did it. We got rid of, or we pulled out the perfect square factor out of 48. So now the problem is we have a root in the denominator, so we're going to try to get rid of that root in the denominator. Multiply both sides by root 5. And then we have 4 root 3 times 5. Again, you can do that in your head and just get root 15. You don't have to show this step. And the bottom, we have root 5 times 5. So then 3 times 5 is 15, and 5 times 5 is 25. And then final answer is 4 root 15 over 5, and we're done. So if you got that answer, good job. Okay, on to the next one here. Now you should be getting the hang of these problems here, so you should be doing most of these on your own now, at least these root problems. So we're going to use, this is probably going to be the hardest type of these problems. We're going to use this principle up here to separate the roots, or the root into 2 roots, and we're going to have to pull out a perfect square out of both of these. Now, I know that 7 times 8 is 56, but that doesn't help because neither of those are perfect squares. So I'm going to have to factor 2 times 4 and put the 7 and the 2 together to get 14, and we have 4 times 14, you see. So that becomes root 4 times 14, and 27, that's 9 times 3. And 9 is a perfect square. So both these numbers are perfect squares here. That's what we want. Then I'm going to use that principle at the upper right there to separate the roots. Again, you don't have to show every one of these steps. Root 4 is 2. Root 9 is 3. And of course, we can get rid of the dots. Now, we pulled out the perfect squares and we made the numbers a lot simpler to deal with, but the problem is we still have a root in the denominator. So now, just to show everything we're doing here, again, I'm showing all the work. You don't have to show every single one of these steps. So it might look like this is really tedious, but for you, you don't have to show all this stuff. So then we get down to 2 root 14 times 3 over 3 root 3 times 3. And then we end up with 2 times, that would be a 52. 14 times 3 is 52. Actually, no, that would be 42, I believe. It would be 42. And we get 9, root 9. But of course, root 9, that's just 3. So we end up with 2 root 42 over 3 times 3. Let me find some more room here. So now we have 2 root 42 over 9. And there you go. So if you got that one right, good job. That was the hardest of those problems where you have to rationalize the denominator. So now we're adding fractions again. Go ahead and attempt this problem. These are calling out to you. These quadratics are calling out to you to factor. So we have to get a common denominator. We're going to factor those denominators to get a common denominator. It's going to help us find a common denominator. What 2 numbers multiply to negative 18 and add up to negative 3? That's going to be negative 6 and positive 3. Again, if you're understanding how to do this, then stop the video. Don't just watch me do it. So now that helps us, factoring helps us to figure out what the common denominator is going to be. Now this is something where students are going to get a little confused here possibly. We have 2x plus 3's here, so that means we have to have 2x plus 3's here. Okay, so just be aware of that. And so I'm going to have to multiply by x plus 3 to get a second x plus 3. So on the other fraction, I don't have an x minus 6. So I'm going to have to multiply by both sides by x minus 6. Remember, whenever you multiply one side of a fraction, you have to multiply the other side. And so, using distribution in the numerator, we have negative 7x minus 21 over all that stuff. And we have 2x minus 12 over that same stuff there. Again, we need two x plus 3's. Okay, now we have a common denominator, so we can add these up. Negative 7x plus 2x is negative 5x. Negative 21 plus negative 12 is negative 33. And then we just rewrite all the stuff in the denominator, and we could write x plus 3 to the second power to make it easier to write, but I'm just going to keep it as x plus 3 times x plus 3. So if you got that answer, that's very good. That was a good problem there. I'm going to make a divider here. So now we're going on to 21. The first thing you want to do is get a common denominator, but we have to factor this difference of two squares first. So try 21, and factoring that difference of two squares, x squared minus 100, is going to help you figure out what the common denominator is. So try 21, and when you come back, we'll do it together. All right, we're back. So I'm going to factor. And again, I want you to show your work on these problems. Don't skip ahead on these. It's really difficult to skip ahead anyway because there's a lot to keep track of here. All right, so I factored this difference of two squares, right? So that's a 10 and a 10. So now I need to multiply both sides of this fraction by x plus 10 to get a common denominator. And I'm just going to rewrite that fraction. Sorry, it's kind of cramped in here. And I'm going to multiply both sides of this last fraction by x minus 10. I'll find some more room here. So using distribution, we have 5x plus 50 and 9, and then up here, oh, whoops, I did something very bad up here, very, very bad. See this right here? You have to put parentheses, orange parentheses there. If you don't put orange parentheses there, then the x, it's going to look like negative 2 is multiplied into these, but the x is not, you see. It doesn't make any sense. So now here's where the part gets it gets intimidating to students. You're going to multiply. We're going to have to use FOIL on this highlighted green thing here. You're going to have to use FOIL. But that's okay. You can do it in your head. X squared minus 12x plus 20. I just did that FOIL in my head, just to save time, because again, if you show FOIL every single time, it just gets tedious. So x squared minus 12x plus 20. Okay, so now we have a common denominator, so now we can go ahead and add these together. But be aware, this is the part where students are going to get the problem wrong. you're subtracting this entire last fraction over here. So you have to change all those signs. That's positive x squared, so it's going to be negative x squared. In fact, let's just go ahead and show all that. So that's going to be negative x squared, not positive x squared. It's going to be positive 12x, not negative 12x. It's going to be negative 20, not positive 20, you see? Because you're subtracting. You're subtracting that entire fraction over here. So now we're just going to write the final answer. Negative x squared, and then 5x plus 12x is 17x. And 50 plus 9 is 59. 59 minus 20 is 39. And that's all over x minus 10 times x plus 10. So there we go. So if you got that answer, good job. Okay, on to number 22. So we have fractions here we need to combine. So again, this expression here is calling out to us. We need to factor that, and that's going to help us find a common denominator. But unfortunately, we have a coefficient here. So we're going to, maybe I'll try 2x and 2x. 2x times 2x is 4x squared. And if that doesn't work, I can try 4x times x. What two numbers multiply to negative 5? 1 and negative 5. If that doesn't work, we can switch the signs. So now we have to FOIL this. I'm going to FOIL this here. F O I L. Combine these and you get negative 8x. Didn't work. So it looks like we're going to have to change those 2x's to a 4x and an x. Now understand that I should have known that. I should have known it was going to be 4x because we have 4x's over here, or not to the right but to the left. So be aware that you can use those as clues. Also, we have an x plus 5, so it's probably going to be plus x and minus 1. Let's just see for sure. So F O I and L. 20x minus x is 19x. So we got it. We got our 19x up here. So now that we factored, we can see what to do to get a common denominator for all these fractions. I'm going to multiply both sides of this fraction over here by x plus 5. And I don't need to do anything with this middle fraction. That's got all the factors in the denominator that we need. But with this fraction over here, I'm going to multiply both sides by 4x minus 1. And at this point, you can see that we now have a common denominator. So it's good to go back and check and make sure that you did everything correctly. When you're doing algebra, it's always good to go back and check. Students just like to plow ahead, but if you do that, it's almost a guarantee you're going to get something wrong. You need to check and make sure you did everything correctly. So now we're going to distribute. We have x squared plus 5x. 4x minus 1 times x plus 5. And again, we can just keep that there. And we have x plus 5. And we're going to distribute, so we have 16x cubed minus 4x squared Again, always go back and check, make sure everything looks right. If you make a mistake and then you do all that work, it's going to be a waste of time. So you want to check and make sure everything looks correct. And everything looks correct. So now again, this is the part that, you know, students are going to make mistakes. You're subtracting this entire fraction. So we have x squared plus 5x plus 8. It's not positive 16x cubed, it's negative 16x cubed. This is a positive 16x cubed. But since you're subtracting that entire fraction, it becomes negative. This is a negative 4x squared, but because you're subtracting the entire fraction, it becomes a positive 4x squared. Those are the types of things that really haunt students when they're taking this this course, because that alone will give you the wrong answer if you don't realize those things. So now we have a negative 16x cubed. X squared plus 4x squared is 5x squared. And we have a 5x and we have an 8. And then just write the denominator. We don't have to multiply the denominator. We don't have to expand it. So that is the final answer. So if you got that answer, good job. Okay, we have 3 more problems. This is a complex fraction, so you know what to do. We have to change that fraction symbol to a division symbol. Again, that fraction symbol becomes a division symbol. When you're dividing fractions, you know that we have to change to multiplication. Let's do that first before we forget, before we confuse ourselves, and flip the divisor. Alright, and so at this point, now we're ready to start factoring. We're going to factor out a 3x squared. That's GCF factoring, and we have a quadratic expression here. What 2 numbers multiply to 7 and add up to 8? Well, that's 1 and 7. 1 times 7 is 7, and 1 plus 7 is 8. Okay, so now, as you can see, we can cancel out these purple x plus 7s, and I think that's it. So we're going to write the final answer. We have negative 2 times x plus 1, and we have 3x squared, and that is the final answer. So you can distribute the 2 if you want to, but I don't really, I'm not going to make you do that. It's not really necessary. So if you got that answer, good job. Let's try number 24. Here's an even more complicated complex fraction. So in this case, what we have to do is combine the numerator and the denominator. Or first we're going to combine everything in the numerator, then we're going to go and combine everything in the denominator, and then we'll worry about translating the fraction symbol to a division sign. But again, this is calling out to us. This expression down here in purple is calling out to us. It's saying factor this. All right, we have to factor that. Whenever you see a quadratic, it's pretty much a guarantee that you're probably going to have to factor it. What 2 numbers multiply to negative 15 and add up to negative 2? Well, that's going to be negative 5 and positive 3. All right, so all we did was just factor this yellow expression here. That's all we did. All right? So that's going to help us. And another thing that's going to help us is to change that 1 to 1 over 1. You see how I changed this blue? I changed that blue 1 to 1 over 1. That's going to help us because now it's a fraction. Now I'm going to take this 1 over x plus 3 and I'm going to multiply by x minus 5 so I can get a common denominator. But it's very important to understand that you can't just do it like this green thing here. You can't do that. You have to write parentheses around the x plus 3 to show that you're multiplying by the whole thing. And so this other fraction, we can just leave that there. So now in the denominator, it's going to be pretty easy to get a common denominator. I'm just going to multiply both sides of that blue fraction by x minus 5. And so now let's get an idea of what this looks like. So we have x minus 5 over x plus 3 times x minus 5 minus 6x plus 2 all over the same denominator. And on the bottom we have 4 over x minus 5 plus x minus 5 over x minus 5, and I don't really need the parentheses there. I can get rid of those. So now you see we have common denominators. The yellow denominators in the numerator are the same, and the orange denominators in the denominator are the same. So that means we can combine those fractions. Now here's the part where students are going to have trouble. I told you before, I'm going to tell you again, when you're subtracting that fraction, all these signs are going to change. So that's a positive 6x. So it's going to become negative 6x. That's a positive 2, so it's going to become negative 2. All right? And we have 4 plus x minus 5 over x minus 5. Alright, so all of this stuff here we combined to this here, and all this stuff in the bottom we combined to that. Okay, so continuing to simplify here. My writing is getting kind of big. Sorry about that. So we're going to combine, simplify more and more and more, and x minus 6x is negative 5x. Negative 5 minus 2 is negative 7. And 4 minus 5 is, oh whoops, I forgot to write the denominators. Four minus 5 is negative 1. And then we have x minus 5. But we're still not done. We have a lot more to do here. Now we're going to change that fraction symbol into a division sign. So we're changing this into division. We're interpreting that as division. And as you go along here, you want to go back and double check all your work. So everything looks fine. So now we're going to flip. And change to multiplication. And now we can cancel out the x minus 5, as you can see. And so we just have one more step. Let me make some more room here. And the final answer is going to be negative 5x minus 7 all over x plus 3 times negative 1 plus x. And there you go. So if you got that answer, good job. That was a doozy. So we have one more problem to do. If you got that one right, good job. we're going to add or subtract this expression here. So it's I'm going to write 3 over 1. And again, you want to try this problem if you can. Don't just watch me do it. If you can do it, do it. If you get stuck, that's okay. But that this is the difference of two squares. It's calling out to me. We want to factor that. And what two numbers, or what number times itself is equal to 64? That's just 8, obviously. And what number times itself is 25? That's just 5. And when you have a difference of two squares, you write plus and minus. So we changed this to a fraction, and we factored this here. Now it's very important to understand that we have 5x plus 8 and 5x minus 8. Or we only care about the 5x minus 8, you see, but over here we have 8 minus 5x. It's not the same thing. So what we can do is in the same step here, we can go ahead and factor out a negative. So I'm going to turn this into, again, you can do multiple things in one step. You don't have to do everything, all separately, because it takes a lot longer to do that. Now, I'm going to do something kind of tricky just to make this easier. You see this -1 here? I'm going to bring that up to here. You see, we can do that. That's perfectly legal. What we could also do is we could change this from positive to a negative, but it's probably best just to write -1 like that. And now I have -8 plus 5x. But if I really want to, I can switch it around and write 5x minus 8. That would probably be better. But I don't want to confuse you, so I'm just going to keep that like that. And another thing that I'd like to do, you don't have to do this, but to make this simpler, what I'm going to do is I'm going to take this negative and I'm going to put it up in the numerator. And that's going to make it 4 minus x. So that reduces the chance of making mistakes later on. Now, if that worries you, if you don't like that, you don't have to do it like that. But in fact, I'll probably just keep it the way it was. I don't want to confuse anybody. But just be aware that you can do that. That's perfectly legal. Okay, now over here, I'm going to have to multiply both sides of this fraction by 5x plus 8 times 5x minus 8. I have to move this over. And what you're going to find is that factoring this expression here helped us to find a common denominator in regards to this fraction over here. But factoring actually hurt us when it came to doing the math here. So what you can do is you don't have to multiply by the red expressions there, because that's kind of complicated. But I'm going to, go over that later on. What you can do is you can just recombine those and just consider them to be, 25x squared minus 64. That's a lot easier to multiply by 3. Okay, and over here, well, I guess I'm just going to keep that the way it is. And now I'm going to multiply both sides of this fraction by 5x plus 8 so we can get a common denominator. Okay, so now multiply all that stuff by 3 and we get 75x squared minus 192. I know those are kind of big numbers, sorry about that. And then remember, here's the part where students are going to have trouble. You're subtracting that, so it's not going to be -4, it's going to be +4. And it's not going to be positive x, it's going to be negative x. Then we have to use distribution. In fact, I'm just going to keep that separate for now. I know it's tedious to have to write all this, but I'm doing this for your benefit. You don't have to show every single one of these steps, but you do have to show a lot of them. Using distribution, we have negative 5x minus 8 all over negative 8 plus 5x. And remember, negative 8 plus 5x is the same thing as 5x minus 8. All right, and now we're ready to combine. So we have 75x squared minus 192 plus 4 and minus x. Be aware of that. And then we have minus 5x minus 8 all over our denominator. And, you know, this is the same thing as 5x plus 8 times 5x minus 8. So that's very important to be aware of that. Those are common denominators. So we have to rewrite that. We can write it in any form we want to. It's simpler to write it in the 25x squared minus 64 form, so I guess I'll just write it in that form. Okay, so, but if that confuses you, you can just write it in, you know, 5x plus 8 times 5x minus 8 form. Negative x minus 6x, or minus 5x is negative 6x. Negative 192 plus 4 is negative 188. Negative 188 minus 8 is negative 196. So sorry about those big numbers there. Then we just write 25x squared minus 64, and you're done. So there we go. Okay, if you got that answer, good job. Sorry this class went a little long, but if you want to take screenshots of all the work that we did, go ahead and do that now. Here's screenshot number 1 and screenshot number 2 and screenshot number 4 and screenshot number 5 and screenshot number 6 and screenshot number 7 and screenshot number 8 and screenshot number 9. But don't go before you get your homework. Let's take a look at the homework. This practice test here is going to ensure that you at least do a little bit of studying. This is mandatory before you take test number 2. We have screenshot number 1, screenshot number 2, screenshot number 3, screenshot number 4, and screenshot number 5, screenshot number 6, and number 7, and number 8. But don't go before you get your answers. Here's the answers for the problems 1 through 18 and 19 through 25. It's not enough that you just attempt the problems. They must be correct. So do that homework completely correctly, neatly, and keep it in order in your binder. And in the next class, we're going to take test number 2. So I'll see you then.